Hello guys, in this video we are going to use a housing price dataset to clean it to find out how we can build a model that can help us predict the price of a house depending on some attributes. Let's quickly dive into the dataset and see how it looks like. So we shall use a data frame and read this CSV called housing price dataset.csv. Yeah, so we shall just get a quick view of the dataset. So when you look at it, we have square feet, the square feet of a house. Yeah, we have the number of bedrooms in the house. We have the number of bathrooms in the house. We have the neighborhood of a house, whether the house is in a rural area, whether it's in a suburb, whether it's in an urban area. We have the year the house was built and probably the price of that house. So each record here represents a house. Each record represents a house. Meanwhile, we have this data set contains records for 50,000 houses, and it has 6 attributes of it has a square feet, bedrooms, bathrooms, neighborhood, year built, and then the price. Yeah. So let's look at the structure of the dataset using str dataset. So you can see that square feet is an integer with these entries here in feet. We have bedroom as an integer, bathrooms as an integer, then neighborhood as a character, then year built as an integer, then price as a numeric value. So let's try to look at how the different data is the different columns are formatted, or the details of each column. So I'll first get a summary of the data. Probably here. So I'll first get a summary of the data. Here you can see that square feet, the minimum value is 1000. Then the median of square feet is 2007. The mean of square feet is 2006. And then the maximum value is 299. Then the one of bedrooms, the minimum number of bedrooms a house has is all houses have is 2. Then on average they have around 3 bedrooms. Then the maximum number of bedrooms is 5. The bathrooms, the minimum number of bathrooms is 1. Each house has, some houses have 1. Then the maximum number of bathrooms are 3. Then the neighborhood here, we shall look at that later. The year built, and the minimum, I would say the oldest house was built in 1950, and then the latest was built in 2021, and then on average, the houses were built in 1985 on average, most of them. The price, as you can see, I think we have a problem here. As we can see, we have a negative price here. Logically, if these were prices and are not including loans, I see negative as something that has to be dealt with. The maximum price is 492,195. And on average, houses are 224,827. I'll try to find out the quartiles of price and see. But before looking at the quartiles of price, let me try to find out if they are missing values. So see call sums df to find out if there are missing values. Call sums of is na in the data frame. So as you can see, we don't have missing values in any of those variables. The next thing is to check or to find out to see which houses have the negative prices. So in the data frame here, I'll try to list all records with negative price here, price less than 0. So while listing all the columns, yeah. So here I'll try to find out that yeah, this is a square feet for this house with this price. This is this is the square feet. This is just an indexing number of the row. Yeah, the position of this data in the big data frame here. Then this is the number of bedrooms, the number of bathrooms, and the neighborhood, the year. This subset of the data tells you that there is something wrong. Yeah, there is something wrong with these prices. And as you can see, there are not many out of the 50,000, so I can just drop them from the data set. Yeah. So I'll create a new data frame called df df clean df clean df clean. Let me just call it df1, and I'll generate a subset of the data from the original df, and I'll consider a condition of df where price is I'll take all those that have prices greater than 0. So here, as you can see, it has eliminated only, yeah, there are around 22 observations that it has eliminated, which that doesn't change much. Yeah. So I'll try to find out, let me first list the names of the data set, data frame 1. Yeah. So I'll try to find out the percentiles of the price. So to find, like, yeah, I'm going to explain that after viewing the percentiles. So I'll use a command called quintile. It's called quintile of df1, and I specifically want for price. Yeah. Why I'm using df1 is because df1 is now clean. Let me just drop df. I'll just remove df2 from the command. df1, I mean df, the original df, from, yeah, so that I remain with df1 only. So when you check for the quintile of it tells us that 25% of the data is below this price, then 50% of the data is below this price. Like the prices that are below 22,100 point that they are 50%, and then 70% of the data are below 279,395, and then all the data are below this price. So that's the meaning of the quintiles. Yeah, then I want to look at the standard deviation of the price. So I'll just use SD, and I need from df1, I need to look at the standard deviation of price. So when you look at this, it means that this price is there are very big variations in price. So I'll just look at the summary of price, specifically price. df1, I need price. Yeah, as you can see, the range here between the minimum value and the maximum value is really big, which actually can help us to talk about this big standard deviation, this big variation in the data. I'll try to to visualize my data and see. First of all, I want to look at how the neighborhood is, because it's the only categorical variable in my data. So I want to see, because it has urban, suburb, and then rural. So I want to see the different. I want to look at the frequency table of neighborhood. So I'll first try to load to include my libraries. Yeah. So here up, I'll use Pacman. Library Pacman. Yeah, Pacman. And then I'll preload, preload. Pload. I'm going to use ggplot, ggplot2, and then I'll also need deploy. Yeah, and then run. Yeah, then when I come down here to start visualizing my data, but before visualizing it, I'll need a frequency table for neighborhood. So in PDF, I'll pipe it with ggplot, and it shall be neighborhood. Let me just copy this name here, neighborhood, and put it right here. So I'll add on geometrics of this is to plot, but I need a frequency table. So for a frequency table, I'll first group by neighborhood, and then pipe it with summarize, because I want to summarize it into a table with frequency, which is equal to the number of each category in my column, and then percentage, which is equal to the number of each category divided by the number of the data of rows in that data frame, any row df1, and then multiply that by 100 to make it a percentage. Yeah, so when I use group by here, so as you can see, it tells me that the houses in rural areas constitute 33.4%, and then those in suburb are 33.4%, and then those in urban areas are 33.2%. Yeah, I'll also try to visualize this data on a bar chart. I'll use ggplot, and aesthetics shall be a neighborhood, and I'll add on the geometrics of a plot or a bar chart, and the fill of the chart shall be blue, and I'll add on the data labels. So I'll use geom text, and the text shall have statistics that are counts, and shall be labels of counts, and I'll vertically adjust upwards by negative 0.3. Yeah, and I'll add on a theme, a classic theme here. So when you run here, it must be able to give you, or to visually tell you, that rural houses are these, then suburb houses are these, then urban houses are these. Yeah. The next thing I want to do is to find out if price, or these variables that where are they? These variables here that are numeric. I want to find out if they don't have outliers, or if they have outliers. Yeah. So I'll try to use a box plot or a histogram for them. So df1, I'll try to just copy these commands and put them here, and here I'll just change to square feet, and then yeah, I change this to histogram. And then remove this. I don't need data labels. Yeah, and then run to find out if I have outliers. Yeah, as you can see, I think I don't have many when you look at that. Yeah, or if you use a bar plot here, I mean a box plot, and yeah, when you look at your data, as you can see, I don't really have outliers for that. And then for I don't need to check for bathrooms and uh, and bedrooms because it's really small. I don't have very big values for those. Yeah, and then uh, for year, as you can see, for year of build, I want to since you when you look at year of year build, when I run a summary of year build, when you look at the summary, it tells us that the minimum value is 1950 and then the maximum value is 2021. But on average, they were built in 1985. So I'm going to segment or to group these into those that were built below 1985 and then those that were built above 1985. So I'm just going to create a new column that has those. So the data frame initially is going to have I'm going to create a column called here groups, here build groups, here build groups. Yeah, I'll just create it here build groups, and then initially I'm going to assign it to below 1985, below the mean year build, and then run. So when you check here, you'll see that I have below 1985, and I'll try to replace in df1 on year build groups, where in the data frame in the original year build here, greater than 1985, greater than or equal 1985, or yeah, just greater than 1985, I'll assign it to above 1985. So yeah, when I run and check back in my data frame, you will see that I have below and above. So when you look at this, 1996 is above 1985. So the next thing I will do after checking for all those is some relationships between the variables. For example, I want to look at let me just yeah. For example, I want to look at square feet and price, then bedrooms and price, then bathrooms and price, then year built and price. So I'll use a correlation test for for price, and first I'll run for square feet. For square feet, square feet. I'll just copy this, and actually I just need to put one because it's df1. So when you run for square feet, it tells us that first of all, this relationship is significant. Yeah, there's a relationship between those, and then the relationship is actually big and it's a positive one, which means that as square feet increases, the price is also increased. Then how about for bedroom? When you look at bedroom, yeah, the relationship is there, significant, but very small. Yeah, but it's a positive relationship. How about for bathrooms? When you look at it, it's also significant, but very small also. How about for year build? Yeah, it's not significant actually, but we can look at it in the model and try to find out if it's significant in the model. So I'll simply let me just take it back to square feet. Yeah, so I'll simply run a model. Linear model to of a house. So the reason as to why I'm using a linear model is because my outcome is continuous, is price. So I'm choosing a linear model. So I'm just going to call it model, and the model shall be a linear model LM. And I'll use price. Price is df1. I always forget that. So it's df1 price, and it's going to be led by in df1 I'm going to have square feet, plus in df1 I'll have bedrooms, plus in df1 I'll have bathrooms, and I'll also include neighborhood, plus the year built, the one which is grouped. Yeah, the one which is grouped. So when I run, and yeah, my model is right there. Just reduce this. Yeah, my model is right there, and I'll just run a summary of my model. Summary of model. Yeah, so when you run a summary here, you can actually tell that, yeah, this is how my model is performing. Yeah, 57.01% of the variations in price are explained by all these variables I've put: square feet, bedrooms, bathrooms, neighborhood, year built. So when you look at the significant factors, it tells us that square feet is significant, bedrooms are significant because of the p-value being below 0.05. Then bathrooms are significant also. The neighborhood is actually turning out not to be significant. The one for suburb, but for urban is actually significant. And then the year built is not. I can remove that. Probably you can find out the reasons why by diagonizing the model. So when you exclude year built, you can actually tell that yeah, there is nothing like an improvement in model performance. Yeah, but yeah, as square feet increases by 1 unit, the price of a house increases by 99 units, and then as the number of bedrooms increase by 1, the price increases by 50,080, and as bathrooms increase by 1, the price increases by 2,825. Yeah, and urban houses, yeah, urban houses have a higher price by 1,562 compared to rural ones. Yeah, yeah, that's how we can create a model that predicts for prices of houses. And in the next video, I'll show you how you can implement this model for maybe an end user, what an end user can use. Yeah, check it out in the next video that will come in very soon. Thank you for watching. Please like and subscribe if this video was helpful for your learning.